picture. So the bearing from A to B, so if you were standing at A and you wanted directions to head towards B, you should take north 32 degrees west. So that doesn't mean that this angle is supposed to be 32. In fact, it's got a right angle there. We know it's a right angle. But from the north line, straight up and down north, you have to turn 32 degrees to the left because that's the direction of west. So that bearing is supposed to fit in right there. Now, at first it's kind of weird that they even gave you that, but you'll see that you do need it here in a bit. The other bearing they give us is from C to B. So if I was standing on point C and I wanted directions to head towards point B, I could start at the north line and turn 68 degrees towards the west line. So if you can't read those bearings to add those two angles to your question, then you won't be able to do this type for us. Okay, part A is not too bad because if you got those down, it wants you to come up with a bearing from A to C. So standing in A, I'd like to head towards C. So we could go from the north line, turn right, which would be towards the east line. And how much are we supposed to turn here?
58.
Good. If this whole thing is 90, and then they indirectly told us this part of it's 32, then this part must be 58. Everybody okay with that? So not too bad if you can read and write a bearing. But part B, I'm going to go about this in kind of an indirect way. Because I think it helps you see what you need to find. There's lots of stuff about this problem you could find, but it's not asking us to solve this triangle, so we don't want to have to find more than we need. But if I would like to know the distance from A to B, that's a side of a right triangle, we instantly know we've got two ways to do that. Pythagorean theorem, if I know two other sides, but finding this length would be just as much work as finding this length. So Pythagorean theorem is probably not a good idea. Or what's the other way to find a side? Okay, so SOHCAHTOA. Something SOHCAHTOA. But for a SOHCAHTOA equation, you need to include the side you're trying to find. You need to pair it up with the side you know the length of. And you also need one of the acute angles. Now, I don't know how big angle B is, and I don't know anything that's going on here. But if I can figure out how big angle C is, I could say the tangent of that is equal to opposite, which is what I'm trying to find, over adjacent, which I know. So my final answer is going to come from 50 times the tangent of angle C. So now I at least know I have to figure out how big this angle C is. That helps me narrow. I'm kind of backtracking. I'm thinking about what am I trying to find? What type of information do I need? So that helps me narrow down to what I still need to find. If I can figure out how big side C or angle C is, I can figure out how long this distance is. Now, this is the part that I'm concerned about because we have not needed this for any other trick, and you had no hint for me, because you wouldn't have this hint for me on quiz day, except from last class when I squeezed this into our notes at the top. Sometimes when you need more angles, and you can try with that picture that we had up there, you can try as much as you want to, you just don't have enough angle information. But if you can find two parallel lines cut by a transversal, any of these angle relationships you used in geometry are welcome to be used here. I'm going to refer to alternate interior angles. So on my picture here, somewhere, okay, do I have two parallel lines in this picture? What are they? Okay, so what I would call, remember how this was a north line and this was a north line? We use those as part of the bearings. Well, a north line and a north line are going to be parallel. So you could think of this as the transversal. Now, I know this is kind of tilted. You guys get spoiled in geometry where it's always written like this. Two parallel lines cut by a transversal, angles that alternate in the interior, like angle 1 and 2 here, have to be congruent. So this angle C is in the, oh, I'm not doing that angle yet, but this 68, the 68 is in the top right of the transversal in the inside. So he's going to alternate with the bottom left of the interior. This and this is one possibility that you could move forward on. These two are alternate interior angles. Again, I can't turn my paper up on the screen here, but parallel line, parallel line, parallel line, parallel line, top right alternates with bottom left. Alternate interior angles are congruent when that is the same. And then finally, that helps because now within this triangle, I know 2 of 3 angles. So the last angle will be what I add to 68 and 58 to get 180. Which is 54. And then that was the last domino to follow before I get my answer. 68.819 meters. Okay, so you need to make sure that you can label some of these bearings to get a couple angles, but when you know you need more angles and you can't just do inverse SOHCAHTOA because you don't have a right triangle and 2 sides, and you don't have 2 angles of a triangle to just subtract those from 180, it's probably that you need alternate interior angles. Now, it's not that our quiz is going to have 5 of these questions on there, but you should expect at least 1 or 2. So, the fact that these were alternate interiors, how I knew this was 68, I used these two, subtract from 180 to find this, and then once I had this, I had enough information to finish my SOHCAHTOA equation. So, a lot going on there. Is there anything specific you want to address? Anybody get that far without any hints? Couple?